we're going to just do a little intro into MBS user services, just as a bit of background, to explain what it is that we're going to demonstrate today. This is the work that David and Dev have been doing over, well, more generally over the past year, really, but more recently, this packet delivery mode is a more recent addition. But just by way of background, it's just useful to recap over the SA2 work that's been done. So this is the familiar 5G core components that we've kind of been working with for some time now. The user plane function, the service management function, and all of the other functions down to the UE. But what the MBS system does is it adds a special version of the service management function tailored towards multicast broadcast, and a special version of the user plane function tailored towards multicast broadcast. And these purple elements are the ones that our colleagues at UPV have been busy implementing, and not just those actually, but there are some modifications to the AMF required to support some new system information blocks, and similarly on the UE side as well. So that's kind of the basic multicast broadcast architecture. And then SA2 also defined these green elements as higher level functions. So in the control plane, the MBS function can be used to configure these higher order user services. So they sit on top of the low level MBS service that the MBSMF manages. And it deals with object-oriented delivery and packet-oriented delivery as well. So the AS on the far right-hand side in blue can configure all of these user services at reference point NMB10, and there's a RESTful API to do that based on OpenAPI. And then in the data plane, the MBS transport function can ingest objects or packets at reference point NMB8, whereas the MBUPF only deals in packets. So the MBSTF can convert objects into packets in some appropriate protocol, and Flute is the one that we've implemented last year. So those are the kind of the basic functions there. But in fact, this isn't quite what has been implemented, because there's a slight simplification in these purple elements, which is shown in this diagram, where the UPV colleagues have effectively combined the multicast broadcast SMF with the SMF from Open5GS, and similarly they've combined the multicast broadcast user plane function with the basic user plane function in the Open5GS project. And so what happens is that you end up with a co-location of the functions, as we can see in this diagram. And that means that the interfaces between them disappear. They get subsumed when you co-locate. And this is all perfectly kosher thing to do in the 3GPP specs. It's envisaged that these functions could be co-located. The one thing that we did have to change, though, was to provide support in the Open5GS core for this co-location, so that we can register them with the network repository function. And so there's a small change that David made to the NRF to support that co-location registration. So there we go. That's what we've been building. And so if you remember, I don't know, ages and ages ago, I drew this map, which is basically a map of everything that we wanted to achieve, but it's a very complicated diagram. So what I've done is I've produced a slightly simpler one just to make it easier to understand. So this is rotated slightly compared with the SA2 diagram. So in this diagram, north is at the top rather than at the right-hand side. If we look at the MBS application provider, it's provisioning these services. So this is still that same reference point NMB10 I was looking at earlier, and the objects and the packets still get ingested over reference point NMB8. And what we've also done is we've implemented this multicast broadcast application function. And this is responsible for hosting and serving these things called announcements, and that tells the client which user services are currently available and how to tune to them, essentially. And the user service announcement is bundled with some other resources as well. So in fact, we store these on the external filing system, and that's how they're shared between these two functions. And the way that we've implemented it, as I explained a few weeks ago, is that we've kind of put both of these functions into the same operating system process. So these are also co-located. It's another form of co-location, if you like. And yes, we advertise these bundles to the application provider over this MBS1 reference point. We can make them available in band, so we can send them to the MBS-TF and send them over multicast in this user service announcement channel, or we can fetch them over a standard unicast reference point, which is this MBS5. So 3 different ways to advertise the service to the client device. So that's kind of the basics. And then this is the detail of what happens in the MBS transport function for object-based ingest. This is something we demonstrated last year, where we ingest the objects, we put them in an object store, we package them, and then we use libflutes to turn them into flute packets and send them to the MB user plane function. But really, what we're going to demonstrate today is the other mode, this other distribution method, which is called packet distribution method. And this is slightly simpler. We just ingest packets at reference point NMB8, and then we put them into a packet buffer, and then we can apply forward error correction, potentially packetize them, schedule them for transmission, and then send them to the user plane function. And you might ask yourself, well, why do we need to get the MBS-TF to do this work when the MB UPF can ingest packets anyway, all by itself? And the answer is that the MBS transport function offers some kind of value-added features. So, for example, we can do rate control. So we know what the provisioned bit rate of the distribution session associated with the MBS session should be. And so this packet buffer can potentially overflow if the rate of ingested packets exceeds what it should be going out from the scheduler. We can also test for various other failures, like oversized packets that this MBS transport function can fragment unless the packet is marked as not to be fragmented, in which case we can send an error message back using ICMP. And then yes, this forward error correction is the other value-added feature. We haven't implemented a FEC system yet. This is just without FEC that we're going to demonstrate today. But yeah, that's kind of the basics. Is there anything you want to add to that, David?
No, I'll come on to some other details as I go through the demo, just the difference between forward only and proxy modes.
Yeah. Okay. Yeah. Okay. Very good. So that's really it. There's a list of specs at the end of the presentation, should you wish to read them, or if you need to get sleep because you can't sleep in the heat or something. But yeah, that's all I just wanted to say by means of a preamble. Any questions before we move on to the actual demo, the interesting bit?
Okay, so what I'm going to do is in this terminal, which I've labelled MBSF, I'm going to run the MBSF. This one's going to run the MBS-TF. This one up here, I'm going to fake being an application provider. And that's just for, at the moment, for sending the packets. So I'm going to use my test scripts that I've put with the MBS transport function in the repository in the test directory. And we've got an Open5G core here, which I will run. So now the core's running. I will run up the MBSF and MBSTF. So we've now got all the network functions running, and I've been using Insomnia to actually communicate with the thing, and this is based on the standard 5G MAG MBSF ones. I've just created some extra types to do the packet interface instead. So if we just create an MBS user service, which is the first thing to do, and then I have some ones up here. So if I pick the forward only mode, and we can have a quick look at the change in the body. So instead of an object distro info, we've got this packet distro info. I'm requesting here forward only mode, which will send encapsulated packets down a UDP tunnel to the MBSTF. You can only use unicast mode if you're doing forward only. And I've said my packets will be arriving from this address. So I've just got an address on localhost port 3000. So if I send that, and I get a response. So the response now has the MBSTF has now responded with its local address. So I can see that's again on local address port 50138. So I can now go up to the command line here, which I've got prepared, 50138. So this is my little test script. It just takes a few parameters. So there's the source address that you want to send from, the destination address you want to send to, which is what was given in this response. And the next two addresses are for the encapsulated multicast. So that's should be the destination and source. I've got those the wrong way around. So we've got our addresses in there. So if I start that up now, we have packets are now being sent. I'm just going to show you what that looks like. So if I start a capture, we are now getting the packets going through. So I'll just stop that so we can have a look at some of these. So if I select the first one, this is the packet going from the test script up at the top. So you can see it's going from port 3000 to 50138, which is the MBSTF's packet receiving port. If I just do a decode as on that and say, delete that one, UDP port 3000, and we set that to IPv4 so we can see the encapsulated packets. We can see that within that packet we've got this encapsulated packet which goes from 127005, as we said we would do in the original thing, to this port, which is the port we also set for the MBS session ID. And then I've just picked a couple of port numbers which are just up here. So this is sending through the encapsulated packets. We can see coming out onto the out of the MBSTF. So this is going to the port on the MBUPF that was generated as part of the MBS session. That's all hidden for you by the MBSF. And again, if I do a decode as, we can decode that as IPv4 so we can see the encapsulated packet. And you can see it has the same multicast details as the original. So this is the MBSTF passing it through, but it's also pacing it out at this point. And then this last one, you can actually see the same multicast packets coming out of the MBUPF heading towards the G-node B. My script just rotates the numbers in these packets, does them all to the same length. So the first packet comes out with 01, next packet comes out with 02, and so on as the data. So it's unintelligible for a UE device to actually do anything with, but for test purposes, it's great. With Wireshark, you can see which packet you're looking at. So if I now go back to Insomnia and we just stop that one. So I'm just going to delete the user data ingest session, pick the right entry. And if I delete that now, that should have stopped. And the other mode, so this next mode is the proxy mode. Oh, I've scrolled too far. So the proxy mode just takes packet data, and in proxy mode, you give it it uses the address that you give in the MBS session, and will put the packet headers on for you. So the packets we're going to send will just contain the data and nothing else. And then the MBSTF will output the data with the encapsulated header at the right pace. And then the MBUPF will forward it on. That's what we should see. And let's just see if that actually works. So we've got a new port number here for the output. So we've got 56326. Now, for proxy mode, we don't want to create the encapsulated header, so I will just remove that information from the test script. So if you only provide the test script the two addresses, it's a simple source and destination and doesn't encapsulate the data. So that's 56326. I'll just start Wireshark capturing the output. And if I do that, we can see we've got our bogus IP version. I need to check that. That doesn't look right. Oh, that's because I asked it to de-encapsulate. I just need to undo that. So if I just stop that and we go and have a look at some of these. So first of all, I just need to remove the rule of these. So that needs to say none, because that packet is not encapsulated anymore. And you can see we just have a UDP packet going from the source to the destination we want, just containing the bytes of data we want to send. So this is proxy mode. Then from the MBSTF to the MBUPF. So again, this is from an ephemeral port to the MBUPF on the port designated. And I just need to tell that to decoders encapsulated. So we can see it. And we can see that's now forwarded on with the address details that we gave in the MBS session with the data included. And then the same packet comes out from the MBUPF out to the G-node B, but with the GPRS tunneling on it. They are the two modes for packet mode. So you can send either encapsulated packets or non-encapsulated packets with your data in. So it could just be a simple RTP stream. If you're using the encapsulated mode, the headers have to match the MBS session you've asked for, otherwise the UPF won't forward packets for you. I think that's it. Any questions?